Okay, now that we've gotten through the introductions and looked at, excuse me, the how the dialog looks and works, let's move on to what you can do with the math functions. That's what the rest of this lecture, the rest of the sessions in this lecture series are going to be about. We're going to cover two tabs each for the next 3 sessions, and we'll finish up. So we'll look at the first category here is the Arithmetic Tab. And you see the drop-down listed there of the different operators that you can have with that, and they're broken into different categories. The first category we'll talk about is the per-value operations. It has 2 subcategories, binary and unary. The unary operations, well, let me back up and say per-value operations. Hopefully that makes sense, but what it is every operation happens the same to each value in the time series. And so if we add 3 to a time series, every value gets 3 added to it. The unary operations aren't probably used very much in the type of data that we normally work with. You don't normally need to take the absolute value of a temperature or the inverse of a precipitation value or anything like that. But these functions are there, these operators are there if you need them. And so we have standard trig, sine, cosine, and tans, the logarithmic to base e or base 10, square root, and inverse, absolute value. You can do any of those things to each value in a time series. And all you have to have is the time series selected. You don't need any other time series to be selected with the main time series to do any of these. Now the binary operations, you do need some other information. And it can be a constant or it can be another time series. So if you're going to add a constant or divide a time series by a constant, then you don't need another time series. And you can just select the one time series, start the math functions dialog, and enter the constant and press compute. However, if you are going to, say, add 2 time series together, and, that might happen if you had, flow at 2 tributaries right above a confluence or something like that, and you wanted a quick estimate of the combined flow. So what you would do there is you would select 2 time series, launch the math functions, make sure whichever selected data set you had as a primary that you wanted, obviously it doesn't really matter for the answer here, and select the other time series under data set and then say compute. So binary options, unary options are per value operations on time series. What other types of operations might we have? Well, we have successive value operations. And these are operations that instead of operating on each value the same, they operate on pairs of values. So to an accumulation will add the previous value to the current value, then move forward and add that result to the next value, and move forward and add that result to the next value. So you see it's not a type of thing that you have another data set or a constant, but it's within itself operating on successive values. The inverse of an accumulation is successive differences, where you take the difference of 2 values and assign that as the result. The time-based successive difference is called time derivative, and that's where you take successive differences, the differences between 2 values, but then you also divide the result by the amount of time between them. In DSSVue, the time is always in minutes. So if you were trying to, if you had accumulations of volume in cubic feet, and you wanted to convert that into flow, you could do a time derivative, but that would give you cubic feet per minute. So then you would have to do another arithmetic operation, a per value operation, to divide that by 60 again to give you cubic feet per second. And that brings us to one use of the general tab, which I'll get to in a minute. But before I leave the arithmetic tab, let me retouch on something I didn't mention. It says up here under binary operations that using values from different time series requires the time series to be aligned. So aligned time series, if you're going to add one time series to another, multiply, divide, the time series need to be aligned. And that just simply means the times in each time series need to be the same. You can't add one time series that's 3 minutes after every hour to a time series that's on every 15 minutes. It doesn't make any sense. You can't do it. But if the time series are aligned, and there are ways of making time series aligned, and we'll get to that later in some of the other operators in the General tab, or excuse me, the Time Functions tab. But anyway, these are the operations you can do here. Now keep in mind that that time derivative I've just mentioned, where you've got flow, where you have volume, you did a time derivative to get cubic feet per minute. You divided that by 60 to get cubic feet per hour, cubic feet per second, CFS. You didn't change the actual units. You just made it so that the data represents those units. Well, here we have the General tab to the rescue, because one of the things that is in the General tab is metadata operations. And so you can set or convert units, you can set a data type. And by converting units, you can convert from English to metric or metric to English if it's in a specified, if it's in a unit that it expects. But you can set the units to anything. And if you've done the mathematical operations to get the values to be right, now you can come in and set the units to be right and the data type to be right as well. So one of the things of the General tab is metadata operations. Another thing we have is value replacement. Now you can replace values in a time series in various ways. You can truncate the values. And these are back again to per value operations. You'd truncate each value, and it would just be the integer result of the truncation. You can round each value to the nearest integer. You can replace specific values. I'll come back to estimate missing in a minute. But you can replace specific values. Say if you had a time series that had a whole bunch of minus ones, and you knew those were really, should be 0 because it just, for some reason, it should have been 0 instead of minus 1. You can go in and replace all the minus ones with zeros by the replace specific operator. Now, to come back to another value replacement, you can replace missing values with actual values. We'll see in a minute doing the opposite of that. But estimating missing is replacing missing values with actual values that you estimate by linear interpolation. So if you got, the value at 3 o'clock is missing, but you have values at, 2 and 4, you can say, well, just give me the average. It's probably what it is, or it's close to that. Don't know exactly, but it's good enough for now. However, if you had a whole string of values missing, you might not be comfortable linearly interpolating a long period. So when you estimate missing values, you have control over whether or how many consecutive missing values it will actually operate on. So I said replacing missing values with actual values. Another category under General tab is smoothing, and that's where we normally replace actual values with missing values because we think they're bad. That's why it's called screening. So you might have data that that the values over the value of 10 don't make any sense. So you can screen that data and set any value over 10 to missing. That way all the remaining actual values are at least within a range that's believable. So you can do that for maximum values and minimum values. You can also do that for how fast the value changes from one value to the next. And this is time-based. It's not just the actual value change from one value to the next, but that value change per unit of time. So that value change per minute from one value to the next. So you can say anything that's changing faster than this rate of change, I don't believe. I'm going to mark that as bad. And the final thing is we'll talk about smoothing later, but you can say, okay, I have smoothed, I want anything that is very far from the smooth variation of this time series. I want to consider that bad. You know, if I want to do a forward-moving average and say anything that deviates from the forward-moving average by X amount, I'm going to consider that bad. Okay, so that's most of what's on the general tab. We're going to talk about one more here is merging. And merging time series is kind of what it sounds like, is like when you have two time series and it will take the values from the primary time series. If they are good, or if they're not missing, if they're not rejected, if they're valid values, then it will use those. If they're not valid values, it will look for that same time in another time series. And if it's not missing there, it will use it. And you can use this to take different time series that may have different quality, values with them, and say, I want this one to be my primary, but if there's something wrong with it, I want to use a backup to fill in. So you can merge time series with that. Okay, that's the general. Most of the general tab. There's one more category I want to talk about, but you might remember that I mentioned earlier that most of the math functions is time series functions. Okay, we get into something here on the general tab that's not time series functions, and so let's talk about that. We get into paired data operations. And there are several things we can do with paired data in HEC-DSS. And, if we plot a paired data record, we see an X versus Y. Well, which parameter gets the X and which parameter gets the Y? You can assign that within a paired data record, and that's one of the operations you can do here. You can say, well, I don't want to see, flow on the x-axis and stage on the y-axis. I want to see them the other way around. You can swap the parameters. Now, that's different than swapping the plot orientation. Swapping the plot orientation leaves the data exactly the same. It just changes the way it is displayed when you plot it. Swapping the parameters actually swaps the x and y and of the paired data record. So you can do that. You can resample a paired data record. You can sort it. You may want to do some of this if you've generated a paired data record from two different time series. And that's the last thing that's mentioned here on this slide, the generation of a paired data record from two time series. If you have a time series of stage and a time series of flow, you don't really know a rating. You don't know how the flow was generated maybe, or it was generated without a rating from some other type of computation. But you want to generate a quick on-the-fly rating between stage and flow. You can take the two time series, run it through this operation, and say, okay, I've generated a paired data record that gives me some sense of getting flow from stage. You can merge multiple paired data records. You can have multiple curves in a single paired data record, and the general tab here gives you an operator to say, I want to thin those out. I don't want all of these curves in my paired data record. I want to delete some of them. So this is most of what you see in the math functions that is not related to time series. Most of it's time series, but we do have this set of paired data operations that become very useful if you're needing to work with paired data records. And that is it for this session. We've covered the Arithmetic tab and we've covered the General tab, and we'll go on next time to look at the time functions and the hydrologic tabs. So come back and we'll do those.